Alright guys, so I think I'm going to skip column 8 or row 8. I think I'm going to skip row 8 because I have lots of unknowns there. Let's just deal with the ones that have little unknowns first. I have about 4 unknowns here. Okay, 5. Okay, let's just deal with the ones that have little unknowns. And okay, so I'm at column 6. Okay, so I'm at column 9. I'll come back to this later. I'm at column 9. Alright, let's get the parameters for this column. We weren't given mass. Remember, this is row for mass. This is column for mass. So for that row, we weren't given mass. Mass is unknown. Okay, mass M is simply unknown. Okay, we were given pressure. Remember, this is the column for pressure P. We are given pressure as 5 bar. So pressure was given as 5 bar. P equals 5 bar. What else? We are given temperature. Okay, temperature column. So we're giving temperature as 200 degrees Celsius. Temperature, okay, temperature given, that's T given equals 200 degrees Celsius. Okay, we're also giving total volume, that's the column for volume. We're giving total volume as 0.2126. So volume V equals 0.2126. Alright, so we have to find dryness fraction, degree of superheat, enthalpy and internal energy. That's what we're looking for. Okay, so first of all, we're given a temperature of 200 degrees Celsius. Let's find the saturation temperature corresponding to 5 bar if it is equal to this or less than this, so we can know if the steam is superheated or not. So from saturated water and steam corresponding to pressure equals 5 bar. What is the saturation temperature? Let's get the steam table. Okay, so this is saturated water and steam. Okay, corresponding to 5 bar. This is pressure coulomb. 5 bar is simply this. Okay, here is 5 bar. This is the temperature corresponding to 5 bar, 151.8. That's temperature coulomb. So temperature corresponding to that pressure is simply 151.8. Alright, so saturation temperature at 5 bar is simply 151.8. So you have equals 151.8 degrees Celsius. So since given temperature given is greater than saturation temperature, it means steam is superheated, and therefore dryness fraction X is equal to 1 for superheated steam. Okay, so let's fill up that column. Here, this is dryness fraction. Okay, so that's a column. X equals 1. Alright, so having known this now, we're given total volume. Recall that total volume V is simply mx Vg. Okay, so this simply means that mass itself is simply what total volume all over dryness fraction times volume at the gas. So all we need to do now is obtain Vg from superheated steam table corresponding towards the superheated temperature, which is 200 degrees Celsius. This is called the superheated temperature. Okay, so from superheated steam, okay, corresponding to the given pressure is 5 bar and temperature is 200 degrees Celsius. Since steam is superheated, it means superheated temperature is simply 200 degrees Celsius. So we simply obtain the value of what Vg corresponding to these conditions at the superheated steam. So Vg is equal to, alright, so let's get superheated steam. This is superheated steam. Let me take it up a bit. Alright, corresponding to 5 bar. This is 2 to 4. Okay, so we have 5 bar here. So we have 5 bar here. This is the pressure 5 bar. corresponding to 200 degrees Celsius. This is 200 degrees Celsius. This is the value for V. Okay, V is simply 0.4252. That stands for VG, as can be seen here, 0.4252. Okay, so VG equals 0.52. Okay, 0.4252, 0.4252 meter cube per kilograms. Okay, so that therefore this simply implies that mass is now equal to, so we say total volume V divided by XVG, and total volume was given to us as 0.2126. Alright, so you simply have 0.2126 all over X for the Dryness fraction for superheated steam is 1 times Vg is given as 0.4252. Okay, so mass is approximately saying 0.2126 divided 0.4252. So this simply implies that mass itself is equal to 0.5 kilograms. So this becomes the value for the mass. Okay, so let's fill that up now for mass. Okay, 0.5 kg. Mass is 0.5 kg. Okay, next up is to find degree of superheat. Okay, of course we all know degree of superheat. Always it remains superheated temperature minus saturation temperature. So degree of superheated temperature simply gives us 200. Saturation temperature is 151.8. Okay, here we go. Superheated temperature is a given temperature, that's 200 degrees Celsius. Saturation temperature is the temperature at the pressure, which is 151.8. So simply subtract the two. That gives us degree of superheat as equal to, alright, so we simply have the value to be 48.2 degrees Celsius. So this becomes the degree of superheat. So let's fill that up. 48.2 here, right? Here 48.2. Alright. Next is to find enthalpy and internal energy. And I told you that for superheated steam, okay, enthalpy, specific enthalpy is gotten. Okay. Okay, so we'll get that from superheated steam corresponding to the given pressure is 5 bar and the given temperature, which is superheated temperature, 200 degrees Celsius. The value you obtain for Hg is simply the value for specific enthalpy. So you simply have, let's roll down there. Let me take this up. This is superheated steam. This is 5 bar. Hg is very third row. 200 degrees Celsius is here. So Hg is simply 2857. So that stands for the value of enthalpy. 2857. Specific enthalpy. Okay. So we'll have that to be 2857. 2857. This is in kilojoules per kilogram. So we obtain total enthalpy H simply by multiplying that value by mass. And mass was obtained as 0.5, okay, times this 2857. This simply implies that total enthalpy H is simply equal to 1428.5 in kilojoules. So that gives us total enthalpy. So let's fill that up. 1428.5. Next is internal energy. Still the same theory from superheated steam. Okay, corresponding to the given pressure 5 bar and given temperature 200 degrees Celsius, will obtain the value of Ug, and that's simply equal to the value of specific internal energy. So we roll down there now. Let me take this up. As can be seen, this is X5. This is 5 bar pressure. This is U, second row to under 200 degrees Celsius here, 2644. So specific internal energy is 2644. So we simply have 2644. Okay, 2644. This in kilojoules per kilograms. So we'll simply convert this to total internal energy, which is simply mass times specific internal energy. So we'll have 2644 multiplied by mass. Mass is 0.5. Alright, so total internal energy is now equal to 1322 kilojoules. Alright, so that gives us total internal energy 1322. Alright guys, so I'll see you in the next video with questions in the remaining columns. Okay, please do subscribe to this channel. If you find this interesting and helpful, please do subscribe to the channel. I really appreciate that. Thanks. I will see you in the next video. Cheers.